Look at the concrete in buildings, the tar on our roads, or the metal in our phones. None of these materials grow on trees. Every piece of synthetic infrastructure starts as raw material dug out of the earth. We call these naturally occurring solid materials minerals. But simply finding a shiny rock in the ground does not mean you have a viable mine. The mineral concentration has to be high enough to make digging it up profitable. Look at this cross-section of a rock splitting open. It helps to think of it like a jackfruit. The rock is just the thick, unusable outer skin. What you are actually looking for is the highly concentrated, valuable mineral inside. When a rock contains enough of that sweet spot to justify the extraction costs, we call it an ore. This map shows exactly where those profitable ores are clustered across East Africa. We find massive limestone deposits in Tororo, copper in Kilembe, extensive petroleum oil in the Albertine Graben, and diamonds in Mawado. The exact physical locations of these deposits dictate where heavy industry is built, driving the economic potential of the entire region. This cross-section shows our two extraction scenarios. The deposit's physical depth strictly dictates the engineering method. For surface-level minerals, like Tororo limestone, we use open-cast mining. Engineers completely strip the topsoil, drill, and use explosives to break the rock apart. Notice the massive hole left behind in this photo. Open-cast mining is relatively cheap to execute, but it requires excavating a massive pit that completely removes local vegetation and leaves a permanent scar on the landscape. On the right side of our diagram, when minerals are trapped deep underground, like Kilembe copper, miners must bore vertical downshafts and dig horizontal tunnels called skadets. They face extreme risks from collapsing rock roofs and toxic gases. Look at the massive structural reinforcements and heavy pipes in this photo of horizontal adits. Moving air, water, and personnel that far underground requires extensive surface infrastructure just to keep the miners alive. Boring deep tunnels and installing heavy safety equipment multiplies the cost of extraction. The deeper the ore, the more expensive the project becomes, severely limiting who can afford to build the mine. This flowchart breaks down the 5 sequential stages of open-cast extraction. First, engineers clear the topsoil. Second, they blast the rock. Third, excavators load the raw ore into trucks. Fourth, the material is transported. Finally, it reaches a factory for processing. In this image, we see the culmination of that process. Raw, solid limestone from the pit is transported to large industrial silos like these, where it is baked and processed into commercial cement. Extracting liquid minerals requires a completely different approach. As you see here at the Albertine Graben, engineers must build tall drilling rigs to bore directly into the Earth's crust and pump liquid petroleum up to the surface. Let's test this logic. If a large gold deposit is discovered 800 meters directly beneath a protected wetland, what extraction method must be used, and what is the primary financial requirement? Because of the extreme depth, engineers must use underground shaft mining, which requires massive foreign capital to secure the heavy machinery. The physical geology dictates the financial reality. This strict financial reality creates a severe economic paradox. Digging up these resources generates massive wealth for the nation, yet the local citizens living directly on top of the minerals often remain impoverished. On a macro level, mining supplies raw materials for local factories, creates manual jobs, and generates vital tax revenue that governments use to build national infrastructure. But locally, the costs are severe. As you can see by this pristine waterfall, extraction near vital ecological zones creates immediate threats of water contamination, wetland pollution, and total deforestation. Because underground mining and drilling require such expensive technology, the projects are overwhelmingly built by foreign companies. This means the bulk of the generated profits flow out of East Africa entirely. The only defense against this imbalance is strict legislation. Governments must enforce fair land compensation for displaced citizens and legally mandate that extraction companies rehabilitate the environment once the mine is empty. This table summarizes the core variables we've covered. Take a moment to review the specific minerals, their locations, the required extraction methods, and the strict pros and cons of the industry. Unlocking subterranean wealth is only a success if the process measurably protects and improves the lives of the communities living on the surface.